Happy morning, students. Welcome to Boosters iSecondary School online classes. Previous class we have discussed about Unit 15, carbon and its compounds. Okay, so the compounds is most important non-metallic element. It is very important for our life. So, how to discover the carbon milestone we have discussed. So what are the classification of carbon compounds, organic compounds of carbon and inorganic compounds of carbon. So the organic compounds are contained in a nature or available in a nature. So inorganic compounds of carbon is limited in the nature. Okay. So what are the special features of carbon? So compounds of carbon monoxide, carbon dioxide, calcium carbide, carbon disulfide, calcium carbonate, sodium bicarbonate. These are the compounds. These compounds are how to formed and what are the property and uses of compounds, carbon compounds we have discussed in the last class. Okay. So in this class we have discussed about same properties of the carbon compounds, that is catenation, tetravalency, isomerism, multiple bonds, allotropy, etc. Okay. So first one is catenation. Catenation means that is binding of an element to itself or with other elements through covalent bonds to form open or closed or ring chain compounds. So this means the catenation. So catenation means that the elements is binding to the itself, okay, or another elements. So it forms here or binding here or combining here itself or another element to form a covalent bonds. This bonds is chain, closed chain or open chain compounds. So open chain is a linear chain. Okay. So closed chains compounds are branched chain or ring chains. So the catenation is a form a linear chain, branched chain or ring chain structure. Okay. So this picture indicates that the branched chain, linear chain and ring chain. Okay. So branched chain is one of the carbon atom has here another carbon atom, that is a branched chain. So for example, we see a picture. So one carbon contains a another carbon and the same for the one carbon atom contains a another. So this is the branched chain. Okay. Linear chain. Linear means that straight line. Okay. So the carbon is present in the straight line. So this is called as a linear chain. Next one is ring chain. This is also a closed chain compounds because these are arranged in the closed. Okay. So this is also called as ring chain. Okay. So this is means that the catenation. Catenation is binding of an element to itself or with other elements through covalent bonds to form open chain or closed chain compounds. So catenation to form a covalent bonds. Why the property is present in the carbons? So large number of organic compounds are present. So the organic chemistry is this with the catenated carbon compounds. Okay, because large number of organic carbon compounds is present. So this property is taken. Okay. For example, starch, cellulose, these are the contains hundreds of carbon atoms. Contain a chain of hundreds of carbon atoms. Okay. So the next one is tetravalency. So tetravalency, the shell electronic configuration of carbon is 2, 4. Okay, it has 4 electrons in its outermost orbit. According to octet rule, carbon requires 4 electrons to attain nearest noble gas electronic configuration. So Carbon has the tendency to share its 4 electrons with other atoms to complete its octet. So this is called as the tetravalence. Already we know that what is meant by octet. Okay. So the outermost shell is completely filled with 2 8 Okay. So this is the maximum level. So the carbon have a 4 electronic configuration of atom or 4 electrons in its outermost orbit. So it have a unstable. Okay. So it have a stable, it share to the electrons to other elements. Okay. Or nearest noble gas, that is neon. So the carbon tendency to share the 4 electrons with other atoms. So it is completely octet. So this is called as tetravalency. Okay. Simply tetravalency means that it shares the 4 electrons because it attains a stable. Okay. For example, methane. Okay. The methane molecular formula is CH4. Okay. The hydrogen atomic number is 1. So the methane is present in 4 hydrogen atoms. So the carbon have a 4 electrons in the outermost shell. Hydrogen have a 1. So the carbon share the 4 electrons and 4 hydrogen atoms share the electrons in the carbon atoms. Okay. So the into mark indicates the carbon atom electrons in the outermost shell and the dot represented the hydrogen atom electrons in the outermost shell. Okay. So this is the tetravalency. Tetravalency means that the carbon atom's outermost electrons is 4, so it attains a unstable become attain a stable. The 4 electron is shared to the noble gases. At the shared the electrons, it attain a stable or complete its octet. So this means that tetravalency example methane, that is molecular formula CH4. Okay. So the next one is multiple bonds. So the carbon atom means share the electrons to the other atoms or elements. For example, tetravalency. Okay. So the tetravalent carbon can form 4 covalent bonds. So the carbon atoms share the electrons, it form a bonds, that is covalent bonds. So these bonds are single bond, double bond or triple bond. Okay. Already we know that the carbon atoms attain a stable, it share the electrons. Okay. So at the time share the electrons, it forms a bond, that is any other single bond, double bond or triple bond. Okay. So the ability of a carbon to form multiple bonds is the main reason for existence of various classes of carbon compounds. Okay. So table shows one of the such classes of compounds called hydrocarbons and the types of bonding in them. Okay. So the carbon atoms to form a multiple bonds. Okay. Why the carbon atoms to form a multiple bonds to share the electrons? The reason the various classes of carbon compounds are existence. Okay. So one of the class is hydrocarbons. The hydrocarbons have a different types. Okay. So this is the classes of carbon compound, that is alkane, alkene, alkyne. Okay, this class is called as hydrocarbons. Okay, alkane. Alkane example is methane. Okay, so methane is a single bond. So methane form a single bond. Okay, so methane molecular formula is CH4. So the carbon atoms share the electrons for hydrogen atoms. Already we know that in the tetravalency. Okay, next one is class of hydrocarbon compound is alkene. Example is ethene. So ethene is a double bond. Already we know that the carbon atoms to form a single bond, double bond or triple covalent bonds. Okay. Alkyne. Okay. Alkyne, the example is ethane. So the ethane is forms a triple bond. Okay. So these are the examples for the or types the hydrocarbon. Okay. So when one or more hydrogen in hydrocarbon is replaced by other elements like oxygen, nitrogen, sulfur or halogens, etc. So this replacement of the oxygen, nitrogen, sulfur or halogen, these are called as functional groups. Okay. So these functional groups, what is functional groups, etc. You are study about in the higher class, that is 10th standard, 11th, 12th. Okay. So this is the multiple bonds. So the carbon atoms to form a covalent bond. This bond has a single, double or triple bond. The example for the single, double, triple bond is methane, ethene, ethane. Okay. So the methane is a alkane class and ethene is a alkene class and ethane is a alkyne class. Okay. The next one is isomerism. So isomerism is the one of the property or special features of the carbon compounds. Okay. So we are considered about the formula, molecular formula is C2H6O. So we are put the name. How to we are naming the organic compound? We can't. Okay. Because the atoms are arranged and hence its structures. Without knowing the structure, we can't name it. Okay. So the to given a molecular formula may lead to more than one arrangement of atoms, so such compounds having a different physical and chemical properties. So this phenomena, that is, the same molecular formula may exhibit different structural arrangement, is called isomerism. Okay. So the compounds that have the same molecular formula but different structural formula are called isomers. So the isomerism is the Greek word, that is isos means that equal and meros means that parts. Okay. So for example, we have to taken into C2H6O. Okay. So this is the same molecular formula but two structure. Okay. A and B. Okay. CH3, CH2OH. B is a CH3O, CH3. So it have a same molecular formula C2H6O but different structure. Okay. So the oxygen atom is coming with a hydrogen. Okay. A. A compoundல என்ன இருக்கு? ஆக்சிஜன், ஹைட்ரஜன் கூட என்ன இருக்கு? கம்பைனா இருக்கு. பட் Bல என்ன இருக்கு? O வந்து செப்பரேட்டா இருக்கு. ஹைட்ரஜன் வந்து கார்பன் கூட அட்டாச் ஆயிருக்கு. ஓகேவா? இதுதான் நம்ம என்ன சொல்றோம்னா ஐசோமெரிசம். ஓகேவா? So the A compound is called as alcohol because it is have a different structure. So the B compound called as ether. Okay. So this compound has a different physical and chemical properties. Isomerism means that same molecular formula but a different structure of the compounds, that is called as isomerism. For example, C2H6O. Okay. So the A compound called as alcohol because this has a different structure. B has a ether. Same reason for the naming. Okay. So this is means that isomerism. The next one is allotropy. Allotropy is a property by which an element can exist in more than one form that are physically different and chemically similar. So allotropy is one of the property of the carbon compounds. Okay. So allotropy means that element can exist in more than one form but physically different but chemically similar. Okay. So these different forms of that elements are called the allotropes. So allotropy means that the element is present in a more than one form. Okay. But the physically different and chemically similar in the element. Okay. Why the allotropy is exists in the existence? Okay. Because the method of formation of preparations. Okay. எலமெண்ட் வந்து என்னது டிஃப்ரெண்ட் பிசிக்கல் ப்ராப்பர்ட்டி ஆனா கெமிக்கலி என்னது சேமா இருக்கும். ஓகேவா? அதுதான் நம்ம அலோட்ரோபின்னு சொல்றோம். எதனால இந்த அலோட்ரோபி வந்து இந்த மாதிரி இருக்கு அப்படின்னு சொல்லிட்டு கேட்டா என்னது எலமெண்ட்ஸ் வந்து ஃபார்ம் ஆகுது இல்ல மெத்தட் ஆஃப் ஃபார்மேஷன் அண்ட் ப்ரிப்ரேஷன் அதுதான் இந்த அலோட்ரோபிக்கான ரீசனா இருக்கு. ஓகே. ஸோ தி கார்பன் இஸ் எக்ஸிஸ்ட் இன் தி allotropy form. There are two types, that is crystalline, amorphous. Crystalline example is diamond, graphite, fluorescein. Amorphous example is charcoal, coke, lamp, black gas, carbon. Okay, so these are the two types of carbon compounds allotropy, crystalline and amorphous. Crystalline example is diamond, graphite, fullerene. Next amorphous example is charcoal, coke, lamp black, gas, carbon. So one by one we will discuss. So the first one is diamond. So in diamond, each carbon atom shares its 4 valence electrons with 4 other carbon atoms forming 4 covalent bonds. Okay. So the diamond, each of the carbon atoms in the diamond, it shares the 4 valence electrons and the carbon atoms forming a 4 covalent bonds. Okay. So it is arranged in the tetrahedral fashion. Okay. So it is a 3-dimensional structure. The 3-dimensional structure, it has a hardness and rigidity. Okay. Why the diamond is hard? Because it is a 3-dimensional structure. So it is a very hardness and rigidity. Okay. So in the diamond, the atoms are arranged in the tetrahedral. Okay. So this is the crystalline forms of carbon. First one is diamond. Next one is graphite. In graphite, each carbon atom is bonded to 3 other carbon atoms through covalent bonds in the same plane. Okay. So diamond is the 4 electrons is shared, but the graphite is the carbon atom is bonded to the 3 other carbon atoms. Okay. So at that time, the covalent bond is produced and the bonds are in the same plane. Okay, the three carbon atoms are forming a covalent bonds in the same plane. So the graphite is a hexagonal type. So this arrangement is held together in a over other by a weak van der Waals forces. Okay. So this is have a weak van der Waals force. This have a very soft compared to the diamond. Okay. Because the weak van der Waals force. So graphite is a three carbon atoms is bonded to other carbon atoms through a covalent bonds. Okay, so this covalent bond is present in a same plane. So the graphite arrangement is hexagonal layers. So it is held together one over other by weak van der Waals forces. Okay, so since the layers are held by weak forces, graphite is softer than diamond. இது என்னது வேண்டவாஸ் ஃபோர்ஸ் வந்து ரொம்ப ரொம்ப வீக்கா இருக்கிறதுனால இது டைமண்டை விட கிராஃபைட் எப்படி இருக்கும் ரொம்ப சாஃப்டா இருக்கும் ஓகேவா டைமண்ட் வந்து 4 கார்பன் ஆட்டம்ஸ் ஷேர் பண்ணும் ஆனா கிராஃபைட் வந்து என்ன பண்ணும் 3 கார்பன் ஆட்டம்ஸ் மட்டும்தான் பாண்ட் பண்ணும் ஓகேவா ஸோ த நெக்ஸ்ட் எக்ஸாம்பிள் இஸ் fullerene. The third crystalline allotrope of carbon is fullerene. The best known fullerene is Buckminster fullerene, which consists of 60 carbon atoms joined together in a series of 5 and 6 members to form spherical molecule resembling a saucer ball. So its formula is C60. So this allotrope was named as Buckminster fullerene after the American architect Buckminster Fuller because its structure remained the framework of dome-shaped halls designed by Fuller for large international exhibition is called by the pet name Bucky Bowl. A large family of fullerenes exists starting at C20 and reaching up to carbon 540. So fullerene is the third crystalline allotrope of carbon. Okay, so the best known fullerene is known as Buckminster fullerene because the American architect Buckminster fullerene make a dome-shaped halls. Okay, so the dome-shaped halls are designed. It is showed in a international exhibition. Okay, so that architect remembered the fullerene is called as Buckminster fullerene. Okay, the pet name is Bucky Ball. Okay, so the fullerene is 5 to 6 series containing 60 carbon atoms. Okay, carbon atoms. These 60 carbon atoms combined together to form a spherical molecules, which indicates the spherical molecule of the fullerene. Okay. So the 60 carbon atoms are joined together to form a spherical molecule. So this molecular formula is C60. Okay. The large family of the fullerene is a starting from C20 to C540. So this is the largest family of the fullerene. Why the fullerene is Buckminster fullerene? Because the American architect remembered it is called as Buckminster fullerene. So this is the crystalline forms of carbon, that is diamond, graphite, fullerene. The next one is amorphous. Example is charcoal, coke, lamp, black gas, carbon. In amorphous forms of carbon. Carbon atoms are arranged in random manner. These form of carbon are obtained when wood is heated in the absence of air. Example, charcoal. Okay, so the crystalline forms of carbon are arranged in their specific particular shapes, but the amorphous forms of carbon is what is this? Arranged in the atoms are arranged in the random manner. Okay, so it is called as amorphous forms of carbon. For example, charcoal, because the charcoal is given here, the wood is heated in the absence of air, we can get the charcoal. Okay, so this is the types of allotropy. So we have discussed catenation, tetravalency, multiple bonds, isomethem, allotropy. These are the special features of the carbon compounds or property of the carbon compounds. Okay, so in this class we have give a PDF. Some of the missing topics or missing questions are given in the PDF. Okay, so you will write the only missing questions. So என்ன பண்ணணும், எந்தெந்த கொஸ்டின்லாம் ரைட் பண்ணலையோ அந்த கொஸ்டின் எல்லாமே நீங்க ரைட் பண்ணிக்கணும். ஓகேவா, இந்த பிடிஎஃப்ல தரேன் நான். ஓகே, அதான் என்ன பண்ணுங்க, அதை கிளாஸ் அப் நோட்ல ரைட் பண்ணுங்க. தேங்க்யூ.